Hi, today we're gonna look at trapping rainwater Leetcode problem 42. This is a hard problem. Given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it is able to trap after raining. The above elevation map is represented by array 0, 1, 0, 2, 1, 0. In the case, 6 units of rainwater are being trapped. Thanks Marcos for contributing this image. And this is pretty straightforward. So this is 1, 2, 3, 4, 5, 6. And because of the graphics, we can easily see how to calculate this. But is it that easy in code? It is not. The first intuition we can solve this is to solve this like starting from here. Let's say like we would have to start from 0, and if this is bigger than 0, we will set this to some left pillar, and we will going to iterate. And if we see an empty space, which means that if it's smaller than the left pillar, we would have some kind of store value, and then we will add 1 to it, and after that we see a bigger left pillar, and we will set it to 2. Then we see 1 here, and we will add 1 to it, 2 to it, 1 to it. We see a bigger pillar, and we will set 3 to it. But the problem becomes here. What if there is no right pillar? So here we're just assuming that there is a right pillar of 1, at least 1. Or else this is not going to work. So it makes it a lot more difficult if you think about that. So one thing we can do is, this is actually a really good example of a two-pointer method. So we will just start from left and right, and after you know this method, this is not very hard at all. Like this would be something like a medium problem. So and we would set like maximum left and maximum right so far, and then we can just select all the waters in between as we iterate through. And if the maximum left and maximum right is the same, we can like advance the left pillar or a left pointer or right pointer, whatever you want. But if one maximum pillar is smaller than the rest, we would actually want to process the smaller maximum pillar. So with that said, let's actually start with it. We'll have left equals 0, right equals length of height minus 1, and we will set max left underscore left as height 0, max right. So this means like max left by far. By far means until the iteration that we have done. Height 0 by far. Come on. And after this, we will just do let's see. A for loop, not a for loop, while loop, while left. We want to set this equals value because we will also calculate the rain even when the left or right is equal. So with that said, let's see if the max left. Let's first start which is bigger, max left is bigger or max right is bigger. If max left is, let's say it's smaller than max right, because it is what we have in the or equals. Then we would actually want to process the left pointer, but we want to have like result, which is the, and we want to add to the result, which is max left but before we do that, we also want to look if the left value is bigger than the max left. If height left is bigger than max left, we don't have to add to the result. We would just set the max left to height left, and if not, we're just going to then we will add it to the result. But you would have to keep in mind that we want to have the minimum of max left and max right, because the trapped rain will depend on the minimum of the max left or max right. So even though it has like 100 on the right pillar, if we only have 3 in the left pillar, it will only store 3, and minus the value at that point, the height at that point, which would be left. So and after this, we would just progress the left value, and same for the right also. Height right is bigger than So for people who don't understand this part, height of right or height of left, why does it have to be, why are we separating these conditions? It's just that if the place is bigger than the max left, there is no water to store at that point. So we're just setting the max right to height at that point, and we are actually If not, we can add, even though we're adding like 0, we can just set it max left, max right, minus height, right. We could set min of max left, max right, like outside of it, but that's fine. And after this, we can just progress the right pointer. And after this is over, we can return the result. And it works. Let's see if it works here. Runtime error. If length of height is, if it has only 2 pillars, it won't be able to store anything. So we'll just say return 0. Okay. Wrong answer. 4, 2, 3. Output is 3 when expected is 1. So let's actually see what's happening here. Let's actually set here print f string min height left, and we'll just, can this work? I'm not very sure if this will work. Oh, 4, 2, 3. I'm actually excited that this doesn't work, so we can debug some. Min 4. Min is 4. Why is min 4? It should not be 4. So let's see. Okay, it's not even going here. That's okay, because if max left, but max left is not smaller or equal. Oh, I'm sorry. Right? Yeah. So this was like a stupid mistake by me. Apologize it. And let's see if this works this time. And it works pretty fast. Normally I would want to see if there are other ways to solve this problem, but this was like too standard 2-pointer system, and it's very straightforward, so I don't even want to know about what other solution there might be. You might be able to use a for loop, but this problem itself is very nice to use a while loop as a 2-pointer method. So I think that's it for today. Bye guys.